The boil-up rate is controlled by adjusting the steam flow to the reboiler. Once column pressures and temperatures are close to specifications, overhead product and bottoms product can be taken off. Ordinarily, the product that reaches the desired purity first is the one that's taken off first. In this case, it's the overhead product. To prepare for the overhead product takeoff, an isolation valve on the takeoff line is opened. Then, when the overhead product collecting in the receiver reaches a predetermined level, a level controller at the receiver automatically opens an overhead product takeoff valve. An overhead product flows to the storage tank. Now, when the bottoms product reaches its desired purity, it too can be taken off. To begin the bottoms product takeoff, an isolation valve on the takeoff line is opened. Then, when the level in the column reaches a specified value, a level controller automatically opens the takeoff valve, and bottoms product is pumped through the takeoff line. At this point in the procedure, there's a continuous flow of product out of the column, and there's a continuous flow of feed into the column. However, the rates of flow may be below the design values for the system. By gradually increasing the feed rate, the product takeoff rates will automatically increase as well, and the startup procedure will be complete. In this topic, we look at the basic layout of a vacuum distillation system, and we examine procedures for preparing and starting up the system. Now let's try some practice questions. The lighter, lower boiling component of the feed mixture rises to the top of the column as a vapor. It's routed to a condenser, where it's cooled and turned back into a liquid. The condensed liquid collects in a tank called a receiver. Part of the liquid, known as reflux, is pumped back to the top of the column. The liquid that's been distilled enough to meet specifications is called overhead product. It's pumped to an overhead product storage tank. The liquid in the hot well acts as a seal to prevent air from being sucked back into the vacuum system. Column temperatures are adjusted by regulating either the reflux rate, the boil-up rate, or both. Sometimes a distillation system needs to be taken out of service and then returned to service after a short period of time, such as when minor repairs are needed. In these situations, a short-term shutdown procedure is used. The basic goals of a short-term shutdown are to stop the flow of feed mixture to the column, stop the takeoff of overhead product, and stop the takeoff of bottoms product. As much of the equipment as possible is kept in operation so that the system can be restarted quickly. To demonstrate typical procedures for a short-term shutdown, we'll use this simplified flow diagram of a vacuum distillation system that separates a binary feed mixture. Keep in mind, though, that the procedures we'll see should not be substituted for the specific procedures used in your plant. In this system, the first steps in the short-term shutdown involve stopping the flow of feed mixture to the column. First, the steam flow to the preheater is shut off to stop the supply of heat for the feed mixture. Then the feed pump is shut off, and the feed control valve is closed to stop the flow of feed to the column. When the level drops past a specified point, a level controller on the receiver automatically closes the overhead product takeoff valve. This stops overhead product from being drawn off and places the system on total reflux. Now, the absence of feed flow to the column also causes the level in the bottom of the column to drop. When the level drops below a specified value, a level controller automatically closes the bottoms product takeoff valve. This causes the remaining bottoms mixture to circulate through the reboiler and back into the column. A temperature controller detects the increase in temperature and automatically reduces the flow of steam to the reboiler. To complete the short-term shutdown and ensure that no product flows from the system, the level controllers that control the takeoff of overhead product and bottoms product are manually set to 0. Then, the isolation valves in the overhead product and bottoms product takeoff lines are closed. While a distillation system sometimes needs to be taken out of service temporarily for repairs, it may also need to be shut down because of an emergency, and in some cases, an emergency shutdown can be similar to a short-term shutdown. For example, some emergencies require only a brief shutdown. Once the problem has been dealt with, the system may be returned to operation. But the basic goal of any emergency shutdown is to reestablish safe operating conditions. This often involves shutting down equipment that could pose hazards if it were allowed to continue running. Backup equipment may need to be left in operation to stabilize conditions. Once conditions have been stabilized, an emergency shutdown will likely involve stopping the flow of feed mixture to the column, stopping the takeoff of overhead product and bottoms product, and possibly shutting off the reflux system and the vacuum system. Procedures such as draining the column and the reboiler are avoided unless they're needed to maintain safe conditions. Of course, problems that can cause an emergency shutdown can vary, so the exact procedures that are followed will depend on the type of emergency. Among the problems that can cause an emergency shutdown are a steam system failure, which could cause a loss of steam to the preheater, the reboiler, or the vacuum system. A failure in the cooling system, which could cause a loss of cooling water. And an electrical system malfunction, which could interrupt power to plant equipment. During an emergency shutdown, it's important to maintain clear communications with plant personnel and to follow company procedures. Following these rules can help ensure the safety of personnel and limit damage to plant equipment, the products being produced, and the environment. When a distillation system is taken out of service with no expectation of restarting it in the near future, such as when extensive maintenance is needed, a long-term shutdown may be required. In a long-term shutdown, all of the equipment is shut off and the system is emptied. In this vacuum distillation system, a long-term shutdown begins with the feed system. First, the steam flow to the preheater is shut off. Then the feed pump is shut off, while the feed control valve is closed. With the flow of feed mixture to the column stopped, the level of overhead product in the receiver drops. When the level drops past a specified point, a level controller on the receiver automatically closes the overhead product takeoff valve. This places the system on total reflux. Stopping the feed flow to the column also causes the level in the bottom of the column to decrease. When the level falls below a specified point, a level controller automatically closes the bottoms product takeoff valve. This causes the remaining bottoms liquid to circulate through the reboiler. To enable that liquid to cool before it's drained from the system, a temperature controller is manually set to close a control valve on the reboiler steam line. An isolation valve in the steam line is closed as well to ensure that no steam reaches the reboiler. The reboiler circulating pump is left on for now to help cool the liquid in equipment. At this point, there's no feed going into the column, and the overhead and bottoms mixtures are being recirculated. To shut down the reflux system, a temperature controller is reset to close a valve in the reflux line and prevent overhead product from returning to the column. Then, the level controller on the receiver is set to reopen the overhead product takeoff valve, so that the product that has collected in the receiver can be pumped to the overhead product storage tank. Once the receiver has emptied, the reflux pump is shut off to complete the shutdown of the reflux system. The next step is to shut down the vacuum system. First, a pressure controller is used to open a bleed valve in the vacuum line to break the vacuum. Then the two steam jets are shut off in the reverse order from the startup sequence. Once the vacuum system has been shut down and the mixture in the bottom of the column has cooled according to procedures, the reboiler pump is shut off. The column and the reboiler can now be drained. Draining the system enables personnel to perform maintenance without coming into contact with processed liquids. It also prevents liquid in the system from freezing and damaging equipment in cold weather. And it prevents the liquid from depositing a residue in the piping that will need to be removed before the system is restarted. In this topic, we looked at procedures for a short-term shutdown and a long-term shutdown of a vacuum distillation system. Now let's try some practice questions. The basic goals of a short-term shutdown are to stop the flow of feed mixture to the column, stop the takeoff of overhead product, and stop the takeoff of bottoms product. When a distillation system is taken out of service with no expectation of restarting it in the near future, such as when extensive maintenance is needed, a long-term shutdown may be required. In a long-term shutdown, all of the equipment is shut off and the system is emptied.